Hello, Matthews Gatos here. Welcome to section 8.2, Solving Systems Algebraically. Before we get into that, let's review what we did in our last video, which is solving them graphically. Since this is a review question, I recommend that you pause the video, try the question yourself, come back and see how you did. So in this question here, I want to know the value of b that will result in this system having infinite solutions. Well, since the number of solutions is the number of intersection points, infinite solutions must have infinite intersection points. So they must be the same graph and therefore the same equation. So I just want to look and compare each of these equations piece by piece. So to go from y to 2y, I multiply by 2. To go from 4x squared to 8x squared, I multiply by 2. To go from -2 to -4, I also multiply by 2. So if that pattern is true, then to go from 3x to bx, I will also multiply by 2, and I would get 6x. So that means the value of b must be 6. Okay, in this question here, we're given information for a parabola, a vertex, and a point it passes through, and the same thing for a second parabola, and we want to find the approximate coordinates of the point of intersections. So again, since this is a review question, pause the video, try it on your own, come back to see the solution. So my tip in this question here is to go to vertex form. We're given the vertex and a point that each parabola passes through. So I want to use that to come up with the equation. So in my first parabola, following the vertex form, I will have y equals a x minus p squared plus q. I always solve for a. 1 take away 3 is -2. -2 times -2 is 4. Add 1 to both sides. Divide both sides by 4 and I get an a value of 2. So my equation, my first equation, is 2 times x minus 3 squared minus 1. My second parabola, again following vertex form, will be y equals a times x minus p all squared plus q. So 0 take away 1, -1 squared plus 4. So 3 is equal to -1 times -1 is +1. Subtract 4 from both sides and I get a is -1. So my equation for my second parabola is -x minus 1 squared plus 4. So now that I have each equation done, I'm going to put it in my graphing calculator and find the approximate points of intersection. Approximate because they are decimal values. So I can see that my first solution would be 3.2 and -0.9, or my second solution would be approximately 1.5 and 3.8. So those are my 2 points of intersection. So in this video, again, as I said, we're going to cover how to solve systems of equations algebraically. So I just want to go back to 10C and review how to do linear systems. So remember, the 2 ways that we solved systems algebraically were with elimination and substitution. So let's review how to do substitution from 10C. Substitution is exactly as it sounds. We are making a substitution. So I can look at this y value here and see that it is all by itself, y equals x plus 3, and I can substitute this new expression for y in the expression in place of the value of y in the first equation. So instead of having x plus y equals -5, I can put what y is, which is x plus 3. And then I have a nice linear equation to solve. So subtract 3 from both sides, divide both sides by 2. So now that I know that x is -4, I can sub it in to my y equals and figure out what y is. So this is -4 plus 3, so that's -1. So the point, remember it's always a point, of intersection or solution would be -4 and -1. So we're going to repeat this process for linear quadratic and quadratic quadratic. But the most important part of solving these systems is the check. So before I get into that, I just want to review with you checking. Okay, we of course can check on the graphing calculator, but I want to review how we can check algebraically. So I have this system and I want to know if either point is a solution to the system. So if it is, x and y must satisfy each of those equations. So let's check the first one. So 3 times 3 is 9, take away 14 is -5. -5 equals -5. That's true. But it has to be true for both. So let's check the next one. So x squared plus 2 times x minus 14 equals 1. So 9 plus 6, take away 14 equals 1. 9 plus 6 is 15. And 15 take away 14 is 1. That is true. So I know that this is a solution to the system. Let's check if this one is xy. So 3 times x minus y equals -5. So -6 take away 0, -5. -6 equal to -5. Well, that's not true. So if it's not true for one, it's not true for both. So I know that is not a solution. So my tip for you is this. A point has to satisfy both equations to be a solution. If it doesn't satisfy one of the equations, it won't be a solution to the system. So let's go ahead and look at the steps for how to solve substitution. Just like graphing, I said it was all about the y. Substitution, it is all about the y. So I want to isolate y in one of my equations and substitute it into the other in place of y. Now I'm going to have an equation that only has x values. So I solve for x in the new equation, and then I substitute again the value of x to find the value of y. Remember to state your solutions as a point and check in both original equations. So let's try an example here. I want to isolate for y. So I look for the y that has a coefficient of 1, or in this case, -1. So I'm going to use that one as my substitute. I'm going to isolate it. So let me write it out. So I'm going to add y to both sides, and I get 2x squared plus x equals y. So that's what y equals. So I'm going to substitute this expression for y in the second equation in place of y. I'm going to use brackets for my substitution. Always use brackets. So instead of 2 times y, I have 2 times 2x squared plus x plus 1 equals 0. So what I have done is replaced the y value with the new expression. And now I just have to do some number crunching to figure it out. So 2x plus distributive property, 4x squared plus 2x plus 1 equals 0. So I have 4x squared plus 4x plus 1 equals 0. So now I have gone from a system of linear and quadratic equation to just a quadratic equation that I can solve. So to solve this, I'm going to factor 2x plus 1, 2x plus 1 equals 0. So I get that x is -1/2, just one solution, because they're both the same. So this is a perfect square trinomial. So since x equals -1/2, go back to where you isolated for y, 2x squared plus x, and substitute in your x value of -1/2. And we can work out what the y value is. So this is 2 times -1/2 times -1/2 is +1/4. And 2 times 1/4 is 1/2. Take away 1/2 is 0. So that means I think my solution is -1/2 and 0. To know for sure if it's my solution, though, I have to go to the graphing calculator and enter one equation into y1, the other into y2, and check to see if it works. So you can see I've put in one equation in y1, the other in y2. I start my table at -1/2, and the check always happens in the table. Since y1 equals y2, I know I've done this correctly. So now we're going to do the same thing with a quadratic. But the process is the same. So I want you to pause the video, try this on your own, and then come back and see the solution. So I already see that y is isolated, which is nice. So I'm going to substitute that in place of y. So in my second equation, I have 6x squared plus 4x minus y equals 4. Now I'm putting brackets there. I always put brackets for my substitution, especially when I have subtraction. So y is really 3x squared minus x minus 2. So let's tidy this up. So I'm going to subtract 3x squared, subtract a negative x, which becomes positive, subtract a negative 2, which also becomes positive, equals 4. So 6x squared take away 3x squared. 4x and x is 5x. And then I'm going to subtract 4 from both sides. Negative 2 is equal to 0. So I have now just one equation just with x's, and it's quadratic. So to solve this, I'm just going to factor. So 3x squared, 6x minus, it factors like this. So set each factor equal to 0 and solve for x. So I have 3x equals 1, which means x is 1/3, or subtract 2 from both sides, x is negative 2. So now that I've solved for x, I need to substitute back into the original equation to figure out y. So you can use either equation, but again, use brackets for your substitutions, okay? Always use bracket for your substitution. So I'm going to go to the one that already has y isolated. So right here, y equals 3 times a third squared minus a third minus 2. Or y equals 3 times negative 2 squared minus negative 2 minus 2. So I'll work each one out separately. So 3 times 1 over 9, a third, take away a third, minus 2. All those just cancel, and y equals negative 2. So 1/3 and negative 2. That's one possible solution. Or over here, like this. And then 2 take away 2 cancels, so I'm left with 12. So x and y. So those are my 2 points of intersection. I can check that on the graphing calculator. And there I go. Original in y1, the other one in y2. Start the table at a third, it equals. Start the table at negative 2, it also equals. So I know both of those are the correct solution. Okay, let's turn our attention to elimination. So again, a nice little 10C question for you. Elimination, exactly as it sounds, we want to eliminate a variable. So looking at my variables, x and 3x, nothing's the same. 2y and negative y, nothing the same. So what I want to do is make one of the variables the same. So I'm going to choose y. So since I have 2y here, I'm going to multiply everything by 2 here to make them the same. Well, same but opposite. So it's fair as long as I do it to every single term because it is an equation. So 2 times 3x minus 2 times y equals 2 times negative 13. Now, looking at this, I can eliminate y by adding. Since they are opposite, I'm going to add. So x plus 6x is 7x. 2y plus negative 2y, those are gone, equals 5 plus negative 25, negative 21. Divide both sides by 7, and I get x equals negative 3. Then I go back to either equation to solve for y. Doesn't matter which one you go to. So let's just go with the first one. So x plus 2y equals 5. So that means negative 3 plus 2y equals 5. Well, I will add 3 to both sides and divide both sides by 2. So I get a solution, which is, of course, a point that I would then check. So the solution as a point is the point of intersection. So we're going to take this idea and apply it to linear quadratic and quadratic quadratic. Let's go through the steps. So just like substitution, it's all about y. So I want you to make the absolute value of the coefficient of y the same in both equations. So if the coefficients are the same, subtract term by term. If the coefficients are the same but opposite, add the equations. So now that y is eliminated, solve for x, and then you're going to follow the same steps as before. Substitute x into one of the equations for y, state your solution as a point, and of course always check your solution. So let's try this one here. So I have a linear quadratic system, which I'm going to solve by elimination. Remember, it's all about y. So since I have 2y here and only y there, I'm going to make them the same by multiplying each part of this equation by 2, and I'll write out the new system. So I'm going to have 2 times 2x squared, 2 times x, subtract 2 times y equals 2 times 0. And then underneath, I'm just going to line up my second equation. Plus 1 equals 0. So since they are same but opposite, I will add. So 4x squared plus nothing, 2x plus 2x, negative 2y and 2y, 0, plus 1 equals 0. So looking at this, I want to go ahead and factor. So I see that this is a perfect square trinomial, and I get that x is equal to negative a half. So I know that that solution is the same for both. So you can see we solved this one way with substitution and another way with elimination, but we still got the same value. So to finish this up, we just need to substitute back in for y in either equation. So I have y equals 2 times negative a half squared plus x. So that's 2 times negative a half times negative a half is a quarter. Plus, oh, I can also substitute x in here. There we are. So we get a half plus negative a half, which is 0. So my point of intersection, or my solution, negative a half and 0. Okay, just like I did last time, we of course can check this. And you can see in the table, check always happens in the table, y1 equals y2, so I know that I am correct. Okay, let's also do this question together. So again, I have a quadratic linear system. Process still the same. So I want to solve this algebraically with elimination. So it's all about the y value. So let's get y by itself over here, just by subtracting 12 from both sides. So I have a y equals and a y equals. Well, this y equals, to make it the same as that one, I'm going to multiply everything by 3. So I'll multiply the y by 3, 3x squared by 3, 7x by 3, and negative 10 by 3. And then we'll line it up with this equation underneath. So since they are the same, I'm going to subtract term by term to eliminate y. So 3y take away 3y is 0. And I have 9x squared take away 0x squared. 21x take away 3x. And negative 30 take away negative 12, negative 18. So looking at this equation here, I notice that I have a common factor of 9. So I'm going to divide everything by 9. So 0 divided by 9, 9 divided by 9 is 1, 18x divided by 9 is 2x, negative 18 divided by 9 is negative 2. So I can see, looking at this, it cannot be factored. So that doesn't mean there's no solution. It just means I can't get there by factoring. So I'm going to need to use the quadratic equation. So x is equal to opposite b plus or minus the square root, b squared minus 4ac, all divided by 2 times a. So that's negative 2 plus or minus the root of 4. And then multiplying everything there together is positive 8 over 2. So negative 2 plus or minus the root of 12. Now, let's just simplify the root of 12 on the side. Remember, I do perfect factor by non-perfect factor, and I see that that is 2 root 3 over 2. So whenever we have these, remember that we love our numbers to be in lowest terms. So my final answer for x is going to be negative 1 plus or minus the root of 3. Okay, so now we're going to figure out what the y value that goes with that is. So over here, there's my 2x values, negative 1 plus or minus root 3. Now we have 2 different equations that we can substitute it in for. So we can go back here. So this was x squared plus, where are we here? So 3y plus 12 equals 3x, or y equals 3x squared plus 7x minus 10. So looking at those, I do not want to substitute it into a quadratic. So I'm going to go to my linear equation. Now remember our linear equation over here, we can just take all of this and divide it by 3 to make the substitution easier. So let's do that. So I have 3y plus 12 equals 3x. So I will divide each term by 3. So I have y plus 4 equals x. Now that is a simple substitution. I do not want to square a binomial radical if I can avoid it. So since I want to solve for y, I'm just going to make it even easier on myself by subtracting 4 from both sides. So I have y equals x minus 4. So if y equals x minus 4, let's substitute our first value of x, and then we'll substitute our second value for x. Okay, so in the first one here, I just do -1 take away 4 is -5 plus root 3. So that wasn't very bad because we chose the right equation to substitute it. So don't choose the quadratic equation if you can avoid it. There's my first solution. And then same thing over here, -1 take away 4, -5 minus root 3. So my other solution is -1 minus root 3 and -5 minus root 3. So these are my two solutions. And even though they are irrational numbers, I can still check those in the calculator the same way that I did before. So there's my equations, and I put my table starting at -1 plus root 3, you can see they are equal. -1 minus root 3, you can see they are equal. And if you want to double check the y values, you can also check if -5 minus root 3, for example, is -6.32. That's another way of checking as well. So to end this section, I just want to look at the perimeter of a parallelogram and the area of a parallelogram. Write a simplified expression for both and solve the system. So perimeter is all the distance around. So let's just write this here. So the distance all the way around. Let's see, I have a 2x and a 2x is a 4x. And then I have a 2y and a 2y is a 4y. And let's add up all our numbers. -6 and -2 is -8, and -6 is -14, and another -2 is -16. So there's my perimeter, which I know is 28. Now let's make this equation a lot simpler by dividing everything by 4. So then I have 7 equals x plus y minus 4. And then I'm just going to add 4 to both sides. So there's one equation, x plus y equals to 11. Second equation, my area is 10y. Well, area of a parallelogram is base, 2x minus 6, times height on the inside, x minus 2. And that's 10y. So 10y is equal to, now let's apply the distributive property. So 2x times x, 2x squared. 2x times -2, -6 times x, and -6 times -2. So tidying this up, I get 2x squared minus 10x plus 12. Now let's make this even simpler by dividing everything by 2. So I have 5y equals x squared minus 5x plus 6. Okay, so I have my two equations and I can solve this in any way that I want. So I am going to use substitution. So I am going to isolate my y, and there's no right choice. It's just whatever you think looks easiest for your question. So I have y equals 11 minus x, which I'm going to substitute with brackets in place of y. X squared minus 5x plus 6. So 55 minus 5x equals x squared minus 5x plus 6. So I have subtract 55, add 5x to both sides. Subtract 55. So that's all 0. That's 0. And then -55 plus 6 is -49. So add 49 to both sides and use the square root principle, or factor the difference of squares, whichever you see it, and you can see that x equals 7 or x equals -7. Now, because I've already isolated y, I can easily solve for the y value by substituting in my x value. So putting it all together, my solution is 7, 4 or -7, 18. Of course, you would check that in the calculator just to see if you're right, but I've already done that, and I'll tell you that we are correct in those two values, but we need to go all the way back up to see which one makes sense, okay? So solving for this, these are solutions to my system, but remember, they might not be solutions to my word problem, which was the area and perimeter. So let's take it up to the top and see if we're right. So these are our two potential solutions. So if I plug in my x and y values, 7 and 4, I can see if that works. Let's check for the perimeter. So if I plug in x for 7, so 2 times 7 is 14, take away 6 is 8. This is a y value. 2 times 4 is 8, take away 2 is 6. 2x minus 6, it's the same thing here, so that's 8. And then this is 2y minus 2, which is also 6. Let's check if we add that up if they have the correct perimeter. So 6 and 6 is 12, plus 8 is 20, plus another 8 is 28. Did we have a perimeter of 28? We did, so we know we're right. If I were to put in -7 for x, all my side lengths would be negative, so that won't work. This is an extraneous point. It is a solution to the system, but not to the word problem. So this is the solution here. So speaking of problems, guy goes into the doctor and says, "Hey doc, my knee's been giving me problems." And by problems, it's if x plus 2 equals 15, what is the value of x? Thought that was pretty cute, as someone who also has problems with her knee, but more of a knee nature than a math nature. So you guys can move on to practice questions 1 to 5, detailed solutions are on D2L, and then move on to the textbook questions as needed. So I hope this video helped, and I look forward to seeing you for the next